Let's do an optimization problem. We want to find the area of the largest rectangle that can be inscribed in the ellipse x squared over 4 plus y squared over 9 equals 1. Now keep in mind what's going on. We're being asked to maximize or minimize something. In this case, it's maximize because it's largest. So the area is our quantity Q in this case, and it's the area of a rectangle. So remember, the area of a rectangle is length times width. So area equals length times width. That happens to be our Q. What we have to do now is draw a diagram, because what's happening is this rectangle is being inscribed in a certain ellipse. Now the ellipse again is x squared over 4 plus y squared over 9 equals 1. So we can use the x and y intercepts to get a quick sketch of this graph. The x-intercepts are plus or minus 2. The y-intercepts are plus or minus 3. So any point on the ellipse, has the order pair x, y. So I've drawn a rectangle. See, this rectangle has been inscribed in the ellipse. Now, if you do that, you see, because of symmetry, this area is going to be, if you look at what's going on, the width is actually going to be twice x, and the length is going to be 2 times y. So our quantity Q, see, area is our quantity Q. The area of a rectangle is our quantity Q in this case. So Q is equal to 4xy. This is the quantity that we are trying to maximize. But we now need to get this in terms of only one variable. So what we do is we use our constraint. Remember, the constraint is that we are inscribing the rectangle in the ellipse. So to get x in terms of y or y in terms of x, you're going to just use the equation of the ellipse. X squared over 4 plus y squared over 9 equals 1. Well, what you can do is you can solve that equation for y. Now I know we have the square root property, but keep in mind that this is an area, so we want the area to be positive. So when we solve for y, we're just going to take the positive square root, okay? So y is actually 3 times the square root of 1 minus x squared over 4. Take a minute or two to actually do the work, or convince yourself of that. So if I replace y with that quantity, what I end up with is now Q in terms of only one variable, and that's what we want. So Q, if I replace y with all of that, I get Q equals 12x times the square root of 1 minus x squared over 4. So now that we have q in terms of only one variable, we can now differentiate. So think of this as using the closed interval method. We technically have to check the endpoints, but the endpoints for this problem, as you might imagine, are not going to give us our solution. The endpoints, let's see, x can be from -2 to 2, and in each case, you actually no longer have a rectangle. So really, we're really just going to be concerned with the critical numbers. So we're going to find the critical numbers. Remember, critical numbers are values of x where the derivative is